press it in the real world and see if it actually clears the screen and resets whatever's on the screen to something like 0. So let's go ahead and try this. We need to simulate this now. So let me go ahead and do self.viewController, and I'm going to call the digit method because I need to put something on the screen in order to actually have something to clear. So I'm going to pass in digit. What does digit accept as an argument? Here's the method in viewController. What does digit expect? Yeah, UI button. So recall that ID is sort of a generic pointer. Sender is the generic name given to the things that send IB action messages. So if I actually want to simulate a button, I could allocate a button, but that feels a little messy. Well, I can actually talk to my UI. I can say self.view, and then I can say, let's see, view with tag. And then I can say, well, give me, let's pick a number, 1. In other words, let's go ahead and type 1. Or let's be more specific, simulate typing just the number 1. So recall that we tagged everything in Interface Builder. What did this mean? Well, let me go back to the nib file. Let me click on the 1. Let me open all the inspectors on the right. Let me click the attributes inspector. And then remember, like 2 or 3 weeks ago, I went down here and then said that I need a programmatic way of uniquely identifying each of the numeric buttons that's not just their string label. Well, there I had 1. So what does this do over here? If I go back into application tests, this method here, view with tag, will literally return to me a pointer to what type of object? Sanity check. A UI button, which descends from a class called UI view. So a button is indeed a view. So what did I do? I literally just simulated typing the number 1. So if I did this correctly, let's go ahead and do this. st assert and true. And now I want to go ahead and assert that self.viewController.deposit label, his text is actually equal to string, quote unquote, $1. And if not, I'm going to go ahead and print something like deposit should be $1. So in other words, I want to assert that it's the case that the text of the deposit label property is equal to the string, quote unquote, $1. And here, little check, why didn't I not just use equals equals? Yeah. Perfect, right? So you don't want to compare the pointers. You want to compare the actual string values, which is equal to string. We'll actually compare them char by char. Now, if I go ahead and click on the error here, expected identifier. Oh, where am I missing? OK, there we go. I had an extra square bracket. OK, so what did I do? 1, I simulated touching the number 1. And then 2, I'm checking in the UI, does what's appearing in the label right now actually match what I, as a human, expect should appear in the label? And notice that I'm using my same IB outlet called deposit label. What is that thing? Well, again, a quick refresher. If I go to my H file, recall that we had these properties a couple weeks ago, a pointer to an account, a pointer to the UI label, a pointer to the deposit. And then if I look at the nib file, and actually right-click on this, I see that deposit label is indeed a blue line that I dragged and dropped over to file's owner, the viewController class. So in application tests, the goal was to test the clear method. How do I test the clear method now? So clearing should yield $0. So let's go ahead and test this. So do self.viewController. And I'm going to go ahead and pass it the clear message. And what do I pass it as an object? Well, to be honest, it actually doesn't matter in this case, right? Because anytime I press the clear button, it's only wired to one method. So if I look over at the clear method, which is over here, notice, am I even using the sender argument? No, so I can kind of cut a corner here because it doesn't matter. And I can simply pass in nil and not have to worry about tagging also the clear button. It's just not necessary. So what do I want to check for after I've simulated hitting clear? st assert true what? What should be what? OK, I'll keep playing. So deposit label text is equal to string. Come on, 0. All right, so that's it. So now we have a test in place that when I run this test suite, it's not just going to test my underlying models, which is purely code-based, has nothing to do with UI and interface, but rather here I'm testing really the user's interactions by simulating the key presses, sending the exact same IB actions that would have been passed themselves, and then talking to the IB outlets to making sure that the UI is responding to those actions in the manner that we expect. So let me go ahead and rather than write out a whole bunch of these somewhat tediously, let me go ahead and open up a pre-baked version that has exactly the same code, but also some additional methods, just so we can take a quick peek. So this is the same overarching thing. Notice I have 3 targets up here, just as before. And in my M file, notice that all of this is the same as we just typed, same as before, same as before. How about deposit? Well, deposit, this is why it was going to get a little tedious to type. Notice the kinds of things I do. So I want to test the deposit button. Recall that test deposit is going to be the first thing executed after setup. So what do I want to do? I want to talk to myself here. Balance should be $0 at first. So I write a comment to that effect. I then try to assert that it is indeed true that the balance label's text is equal to the string, quote unquote, 0. And what's going to happen if this assertion fails? That's it. This method will terminate. I'll get a red message on the screen. My other tests might still run, but I need to fix this before I can proceed to test yet other things here. So now I pretend to deposit $1. How do I do that? Well, just as before, I pass to the view controller the digit message, and I pass in view with tag 1 to effectively simulate pressing the number 1. Then I go ahead and simulate pressing the deposit button, passing in nil, because I don't care about what button hit deposit. There's only one of them, just like the clear button. And then I assert a couple of things. Once I hit deposit, I want to assert that the deposit label is now 0, and the balance label is now 1, because it's been moved from the top of the screen to the bottom of the UI. Then I didn't want to stop there, right? I could still have something wrong whereby maybe the first deposit works, but the second one doesn't. So this time, let's not only try depositing a second amount, but what also have I consciously chosen to deposit here? Not just another $1, but a 2-digit value, right? This is the opportunity to think about, like, what could I have screwed up? Did I screw up corner cases like double-digit numbers or triple digits? Certainly something more than 1. So let me wave my hands at some of these details. But after I deposit $12, I should hopefully see $13 in the balance. And then I figured this was enough unit tests. Now, if I realize subsequently that, damn, my TF or I found some other bug in the code, writing a regression test would be about going back in here, writing a new test that tests some other thing that I wasn't anticipating, and then making sure that that subsequently always passes. What about testing digit? This one's a little more interesting because there's a lot more corner cases to consider. So when I push a digit button, like the number 0, what should be the case? Well, by default, the deposit label should be $0. If I input a leading 0, this is a good one to test. So let me go ahead and simulate the digit message with an argument of the 0 button. And what should it be at the end? Should still be $0, not 00 or something like that. Then if I input a 1, then if I input a 2, that should hopefully yield me 12. So in short, this is finally the opportunity whereby we might have always, especially in 50, preached, like, think about corner cases and test zeros and negative ones. You can literally now make those tests yourself so that you know with confidence at least your code is correct with respect to the framework you yourself have written. Yeah?
So if we have this test digit, why do we also assert in the other methods that the label is still 12?
Good question. So if we're testing one thing here, why did we seem to be redundantly testing it elsewhere? You don't have to do it that way. And in fact, there's this notion in unit testing called mock objects. And the idea is that you really try to test only the method in question. So I'm kind of being a little lazy here in that I'm testing the deposit button as well as the key presses in one place. And a mock object would essentially mean that you actually implement a fake version of the digit method or of the clear method so that you know that its value is just always going to be some sentinel value. But because these are relatively simple programs, and I think in terms of learning the stuff, I think it's a little easier to just write more intuitive tests. But ultimately, we would not want to test multiple methods in the same test routine generally, if that makes sense. All right. So, and then tear down, this is commented out. I actually don't need to do any teardown because I haven't done anything interesting. So we can essentially leave it at that. So when I actually choose then my application tests and I click run here, not run, click test for this target, notice that it builds, succeeded. Notice that the simulator pops up, immediately quits, but that's good because the test succeeded. And if I actually do something wrong, let's go up to test clear, and let's say deposit should be 1. Well, let's actually change this to like 1,000, which is definitely wrong. So now let's rerun the tests. The simulator should pop up again after the build succeeds. Ooh, test failed, and I now immediately see which line of code failed some test. And I can now try to hone in on what the mistake actually was. Yeah? It's a good question. I believe, it's a good question. I don't know. I suspect there is no guarantee that they will be executed in order because they should all by design be independent. But it will always be setup, method, teardown, setup, method, teardown. Yeah?
Once one of the tests fails, will it go to another one at all? Or do we, like if we say we corrected that, do we have to worry that another test might fail after that? Or does that imply that all the other ones are fine?
Good question. So in this case, I've just made 2 mistakes in test clear and test deposit. The assert will kill execution of the code where it fails, but the subsequent methods will still get called. Which is why, again, the upside of writing unit tests, especially if it feels tedious, the motivation is keep them nice and small so that they're really testing individual things. Other questions? All right. So some words on evil hangman, and so that we have an opportunity to discuss some possible design issues. I'm scrolling down here in the spec, to the various features and design constraints, just to strike up a conversation as you submit or start your alpha for tomorrow, what kinds of things you want to be thinking about. So ultimately, your application has to do a few things. When it starts up, you have to load the dictionary of words from the plist, and then what needs to happen next? What kind of UI elements do you need on the screen? Okay. What's that? Okay, so a label for what?
For having your guesses.
Okay, so for the guesses, so I'll just draw that as a rectangle, but assume that the UI, the aesthetics can be whatever you want. So this is this is a UI text field. What else do we need on the screen?
Do we need the keyboard to be there for input?
Okay, so we need some kind of keyboard. So I'll just depict this with some keys like that. What else do we need?
A label to display the word.
Yes. So we need a label to display the word. Okay, so word and guesses. So let's assume that this is, there's 2 things here. So one is the word that you're trying to guess. So I'm going to draw it just as placeholders, but you can do it any way you want. And then maybe we do need another label to show the letters of the alphabet that you've guessed or not guessed. Some kind of feedback mechanism. What else might we need? Yeah?
How many guesses do you have left?
Yeah, so how many guesses do we have left? So we need some kind of label or some kind of UI mechanism. As I showed last week, I chose to use a UI progress view just because I thought it looked a little sexier than a number, but you can do whatever you want. But another UI widget here. Anything else?
A button to change the settings.
A button to change the settings. Okay, so if you follow the template of the utility application, could be something over here where this is settings, and that'll flip things around. You can still use the little I in the bottom right-hand corner, but if you're using the built-in keyboard, it's going to be a little hard to access that, so you should at least move it or change the functionality to be this button. Yeah?
I was going to ask if it was okay just to use the I.
Good question. Yep, absolutely. You can just use the I if you want. Yeah?
Button to start a new game.
What's that? Yeah, so we need another button to start a new game. And realize I'm a little biased here. I'm essentially drawing my version of this. But you can do this. Any interpretation is fine. All right, so that's pretty good. So some of the design considerations. One came up before class and on the help boards last night. You've got 140,000 words in this dictionary, and one of the constraints in the spec is that the user should be able to choose word lengths between 1 and the maximum length of the words in the dictionary. So do you hard code this? Maximum, N, we call it in the spec. What are the options here? You can hard code it by skimming through the list or writing a little script that finds the longest word or sorting them by length and then just counting the letters manually and then hard coding that with the sharp define or a const. That's one approach. What's an upside of that? It's fast. It's correct. The spec only requires that you support words.plist. So in theory, the dictionary is invariant. But downsides? It could change, right? Like, for the spec, we only require words.plist, but does it feel like the best design to hard code that? And then anytime you update the dictionary with every update to your app store, like, it rubs me the wrong way, right? Feels like we might as well figure this out dynamically so that we're not introducing a potential mistake. And frankly, on a gigahertz whatever device, like, you can search 140,000 words pretty fast and figure out the maximum length. So I would encourage you, from my own design perspective, just figure it out dynamically probably, unless you find that it's crazy slow, but I don't think you'll find that to be the case. But again, argue it one way or the other in your design document.